educational purposes only. The content is not intended to diagnose, treat, cure, or prevent any diseases, nor is it intended to take the place of your primary care physician. The statements in this program have not been evaluated by the FDA. Testimonials are shared as individual experiences of the individual. Results vary and may not be typical. We do not make any claims regarding health or income. As an empowered individual, you do have options available. We are honored to continue to share the teachings of a founding father of the science of epigenetics, Dr. Joel Wallach, Bachelor of Science in Plant and Soil Sciences, Doctor of Veterinary Medicine, 4 postdoctorates in pathology, naturopathic doctor. This program is for educational purposes only. The content is not intended to diagnose, treat, cure, or prevent any diseases, nor is it intended to take the place of your primary care physician. The statements in this program have not been evaluated by the FDA. Testimonials are shared as individual experiences of the individual. Results vary and may not be typical. We do not make any claims regarding health or income. As an empowered individual, you do have options available. We are honored to continue to share the teachings of Hello, everybody. Let's go ahead and wake up the waiting group. No, let's just let them in as they are already awake. Hello. Welcome to Daily with Doc and Becca. My name is Becca Dukes, and if you're live with us in the live Zoom, make sure that you have that chat open. We don't have Marilyn today, but we're still going to have some notes going in there. And if you have questions, go ahead and put your questions in the chat as well. For those of you who are watching us out on any of the different platforms, make sure that you like and share, send us some love, and subscribe to our channel. Also, type in there where you are joining us from. We want to know. So this program is for educational purposes only. We do have to say this. We don't want the FDA to come down on us and say that we're doing anything we're not supposed to do. So I'm super excited, though, because we have a lot of animal lovers in our audience and just around the world. And I can't think of anybody better. Well, no, there's Dr. Wallach, and then there's Dr. Judy. So I'm super excited to have Dr. Judy with us today, because we're going to be stepping into a fascinating conversation that begins with the world of horses, but may challenge how we think about human health as well. So joining us today, we do have Dr. Judy Reynolds, PhD. She's an educator, she's a researcher, she's a nutrition expert, and someone who has spent years connecting dots between science, feeding strategies, and whole body function. Dr. Reynolds is a graduate of Texas A&M and has taught science at the college level, helping students understand complex biological systems in practical and meaningful ways. Her work has also included formulating horse feeds and developing feeding and nutrition programs, including working with ADN, giving her a unique perspective at the intersection of research, nutrition, and real-world application. Well, today she's going to be sharing some of her very own research into hyperkalemic periodic paralysis, or HPP, a condition seen in horses that can appear almost mysterious in nature, where muscle function changes, episodes occur unexpectedly, and severe cases can be life-threatening. Dr. Reynolds is also going to explore the human side of this conversation, looking at nutritional deficiencies, everything that comes with it, and questions around how nutrition may influence function and the resiliency of the body. So, Dr. Judy, thank you so much for joining us today. I am super excited as this is some of your very own research, hands-on, in the moment that you have done, and I am excited to be able to share it with our whole audience around the world. And I'm especially excited when you get to how it relates to some things that go on in the human world too. So thank you so much. I know you've got an amazing presentation put together, so I'm just going to turn it over to you if that's okay.
That is awesome, Becca. Thank you so much for the invitation. I love being here. And this is a special one for me because, like you said, this is my research. When you do a PhD, which is, basically that means you're studying, but you also have to do research and you have to defend your research and all that. Just a quick comment on who gets called a doctor and who basically doesn't get called a doctor out there in the world. So two main groups of people, we are officially called doctor. In other words, you say doctor and then your name. Number one, the medical doctors, which we know, MD, those are medical doctors. And then there are PhDs. That's called a doctor of philosophy. And PhDs do two main things. They do research and they educate people. But they're also called a doctor because they had to go through a research project. They had to defend it, not just do things that you can do with learning, taking courses, things like a master's degree and things like that, you can do that way. The other kinds of people that basically have a doctorate would be your lawyers. They're a JD, a Juris Doctorate, but they don't call themselves doctors. And then there are people like EDDs, education doctors. In other words, if you're in education, say you teach high school or something, and if you keep teaching for years, every year you have to get continuing education credits. And if you're smart, you're going to group those. And eventually, if you're a teacher, you will get a master's degree as a teacher. You'll get a master of education. And then if you keep doing that for a long period of time, you can get a master or a doctor of education, which is an EDD. And those people are not supposed to call themselves doctor. They're a doctor of education. But as we all know, recently there have been people that have done that. And it's just kind of confusing, but for whatever that's worth, I just thought I would throw it out there. So what I'm going to do today is this is basically a mystery. I talked about epigenetics last time, and that's basically when things happen to the genes or to the process of going from genes to proteins and building our bodies. And then we have this problem and we're trying to solve it. And can we use diet or not? And that's a big thing that we do. We're trying to make sure we all get all the nutrients we need so that we can do the functions that our body's able to do. We have to try to be able to do that. So here's what happened, basically. My husband and I had a business where we trained and showed horses when I was young. And we would go to these horse shows. And this was in the 1980s, from 1980 through 1983. We did the Minnesota Quarter Horse Association circuit. So we went to all the quarter horse shows, and quarter horses are a specific breed, usually known for being muscly horses. But there's an association for that. So we went to about 40 shows a year doing that, the breed, those breed shows in the state of Minnesota where we lived. And we actually won in 1980 the High Point all-around horse in that association. And then each of those 4 years, we won the High Point performance horse, High Point performance gelding, and things like that. So that's what we're basically famous for doing that. But while we were at those shows, we did the speed events, the barrel racing, pole bending, and so basically speed. But each day they would have the whole show, and they start out the shows with halter, which is where you're just looking at the animal. You're looking at their muscling, You're looking at how they're built. So that's more like a what are the genes or what does the horse look like? And while we were going to those shows, some of the horses started, and it was mainly the ones doing the halter classes. They would have this weird shaking that they call fasciculations, and they would have to call the vets out, and they would be, trying to deal with this. And this went on for years, probably 10 or more years. And some of them would even be found dead in their stalls in the morning. It was really a bad thing. So at the time that I was doing my PhD research at Texas A&M, which was later, it was 1990. I was down there from 90 through 95. There was a big breakthrough that they found the genetic cause of that disorder. So we knew what it was, what caused it. And I decided to do my project on it. There's a magazine called Equus, and the horse people know what that is, but I was actually a charter subscriber. It's a magazine that would come every month, and they would talk about what's going on with the medical stuff with horses. It was basically anatomy, physiology, all the stuff going on, not a riding, what's going on with riding, but what's going on with the physiology of horses. And there was an issue of that said unmasking the fatal flaw. And it was about the genetic discovery of HYPP, what it is. And it happened to be at a time, like I said, where I was interested in it. But the other thing was at Texas A&M, as part of the horses that they keep, they breed and train and show horses and sell them. They have to have them for the students to use. And they happen to have one group of horses that went back to the Stallion Impressive. I'll show you in a minute, but this problem happened to be in descendants of that horse. So at the college I was at, University, Texas A&M, there were actually horses that had that disorder, some that did and some that didn't. But the interesting thing there is none of us knew that they were even having symptoms of it. Because if you're fed a certain way, they don't have symptoms, which we're coming to. So, it becomes kind of a fascinating thing. But in order to sell, I believe it was the 2-year-olds or something, from that one year, they started having rules. Once they figured out what it was, and if you're going to send a horse to sale, you have to test it and make sure that it doesn't have it, or if it does. So those horses were all put up for sale, and they were all tested. And they were shocked at Texas A&M to find out that roughly half of those horses had it, which is statistically what you would get, about half. And so I'm going, wow, perfect. And I planned and put this whole project together. So I'm gonna go ahead and start out and do some definitions. But key things that we're doing as we're trying to solve this mystery, again, we found out the genetics. So we're going to look at the genetics, we're going to look at the physiology. It has to do with muscle cell membranes, thus the muscle, the fasciculations and things. It also has to do with the heart, the functioning of the heart, and it's the electrical conduction system. So we're going to look at some of those EEGs and those kinds of things. We're going to look at both human and horse versions. And then we're going to go through how the project was designed, what the results were, and how the basic mystery was solved and how we can now feed them. So again, this is a mystery, but it covers all kinds of disciplines and all kinds of things that I think are interesting. And so that's the payoff here, is that it's the process. We're going to go through the process. All right. So here we go. Okay, so again, it's called hyperkalemic periodic paralysis, and we'll define it. First thing, it's always nice to define things. Okay, so hyper is from the Greek, meaning hooper, meaning above or excessive, too much. Kalemic is the Latin. Kalium is potassium in Latin. Periodic means repeated cycles. Sometimes it's happening, sometimes it's not, going in cycles. And paralysis, inability to move. Okay, so that's why it was named. They used the symptoms, and that's how it was named. But it's got a bunch of other names too. Remember, everything gets named more than once, so we'll see those in a second here. So just to introduce it, we know that it's co-dominantly inherited. What that means is that a horse can have symptoms when they have only one. We're looking at the whole thing where you get one gene from the mother, one from the father. And if they only have one, they'll have a certain set of problems. But if they have both, they have even more. So it's not just if it's a recessive type thing instead, then the ones that have one copy don't have any symptoms. You don't even know they're sick, but they carry it. Okay, so that's not what this is. This is dominant. So we knew that. We know it affects muscle function. They pretty quickly figured out that all the horses that had this were a descendant. Now, they could be a son or daughter, they could be a grandson or granddaughter, they could be a grandson or granddaughter, they could go, generation after generation, they could have this. So, but they did trace them all back. Okay, and then the thing is, there's a large variation in symptoms. They had several years of these horses at Texas A&M and never realized or knew the vets there. I had 2 veterinarians on my committee to do this project. And, they're like, no, we've never seen it. Of course, we didn't know it. They didn't know what it was, but they never saw what other people were talking about. Okay, and then they did have that genetic test. So what we found, of course, is that you have to manage them. Since they might be a little bit sick or not sick at all, or a lot sick, we had to figure out how to manage it, and that's where the diet starts to come in. Okay, this is what the horse looked like. This is from Equus magazine, and this is what you'd call a beautifully shaped muscular quarter horse. Okay. Now, the thing about this is when people see a horse like that, they breed for his qualities. So he was a very popular sire. And that's why. If this horse had been a bad looking horse out in somebody's pasture, he probably would have been gelded and no one have ever heard of this disease. But because he was so nice looking, he was a top sire and had a lot of offspring. And there's a key thing about that we're going to talk about in a minute too. Okay, so when you're doing research like this, you do a literature review. So I went through and I had to learn about potassium metabolism. I had to learn about that genetic mutation and other things about genetics. I had to learn the mechanism of action. How does it work? What are the symptoms that people see? And the diagnosis, and then what do the veterinarians do to treat something like this? So here we go, potassium metabolism. Now I'm going to show you a diagram in a couple of minutes. I'm going to go through this, but then I'm going to show you a diagram, and that's sort of confusing, but it's better than all these words. But so what happens with potassium? Okay, we have, if we look at the internal makeup of the muscle, you have cells. Each individual cell has a lot of potassium in the cell. And then in the blood, we have a lot of sodium. And so for muscle cell membranes to what they call fire, for a muscle to work, to move, you have shifts between the potassium that's in the cell and the sodium that's outside the cell. And you have pores and ways that they can interchange. And when that happens, the muscle can move. Okay, so that's required. So what happens is potassium itself is the principal intracellular cation. So it's inside the cell. Cation means it's a positive charge. Okay, so it's missing an electron. So it maintains the cell volume and allows for that electrical activity. Now, this whole thing is regulated by hormones. Those are chemical messengers that go from one part of the body to another, mainly in the kidneys, the adrenal glands, which are above the kidneys, the thyroid gland, and the pancreas. You're probably familiar with all of those. Most potassium is absorbed from the small intestine, but a small amount from the large. I actually did a separate study on top of this with ponies that had been there from another study. And so they had a cannula that goes in between the small and large intestine, and we could take out some of the digesta before it went all the way through, and then at the end, and we were able to figure out that most of it does get absorbed in the small intestine, but some of it in the large. So that was a whole separate thing that I did. Okay, so mostly it's going to get absorbed, and the potassium that they eat is going to get absorbed and be in the blood. So once it's in the blood, the main way to excrete it is the kidneys. That's how we get rid of our, the liquid things. But there's some will come out, the feces, sweat, and dermis, which is skin. It'll be in the skin cells, and all those cells have a lot of potassium. So when you shed skin, that's gonna go too. And here's a key thing right here. Horses require 0.3% to 0.8% of their dry matter intake. And that's just a way that we measure. A horse gets about 20 to 30 pounds, an 1,100-pound horse gets about 20 to 30 pounds of dry matter as feed and hay, or they're going to eat pasture, which is 70% water, and then you just calculate it by the percentage of water in the diet. But look at this. Common feeds supply 0.3 to 6%. Okay, this is what they need, and here almost 10 times as much. So literally almost all horses are getting too much potassium every day, all the time, and they have to get rid of it. Okay, normal horses, but they can get rid of it. They don't have a problem. But these horses do. They have this big problem trying to get rid of it. Okay, and here's the part about humans. Now, this is when I did the research. I was doing this in about 93. I finished my actual master's work in 93 and started working on this. And so I did the literature review at that time, and I found 18 missense mutations. It's in this same channel. I'm going to show you this. I don't know why my pointer isn't showing up here, but I'm going to show you a picture of this. So again, I'll go through it and then I'll show you a picture. There is this skeletal muscle sodium channel. So the purpose of it is to open up and let the sodium go through. That's what that SCN4A does. That's its job. And in humans, there is one called the same thing, hyperkalemic periodic paralysis. It's also called adenemia episodica hereditaria. It's called Gamstorp's disease, hypokalemic periodic paralysis, and those are people where at the time it happens, they don't have enough potassium in their blood. Then there's paramyotonia congenita and PMC of von Eulenberg and myotonia congenita. These are all things that I found in the literature that can happen to people. This will make more sense as I show you the graph, the chart. Okay, let's also go through this one before I get to the other diagram. Okay, they had 2 people with HYPP, what they were calling it in the human literature there. And then they had, I believe it was 9 normal subjects. So what they did is several times, repeatedly, they gave these people, this is, you can see here, this is their potassium content here in the venous blood, in the veins. And then this is 8 in the morning, this is a meal, 12 noon, a meal, 6 p.m., I believe, a meal, and then 12 midnight, 6 a.m., 12 noon, and 6 p.m. Okay, so they got meals at these times. Okay, you can see the normal people at somewhere around 4, and then you can see that it stayed in a pretty much the same range, around almost 4. And the normal range, people say, is 3.5 to 4.5 is supposed to be the normal range of potassium. It's kind of a useless concept, but that's what they basically said it was. But you can see that these people that had this mutation, now my pointer's working, you can see how at the meal, it would go up. And it went up to 5. This one went up to 5.25 or something like that. So you can see that after each meal, so in other words, the meal was the source of the extra potassium, and it would go up like that. Okay, so this is people. That was humans. Okay, so now how do these two compare, the horses and the people? Okay, the human HYPP is similar to one human mutation. So it's basically the same mutation. The other ones are close, but not in the same place on the sodium channel. Again, I'll show you that in a minute. So equine HYPP is also called HPP, HyperPP, PIPP for potassium-induced periodic paralysis. Because again, people in one place call it one thing, they call it something else somewhere else. But the one, so we know that there is this one mutation, and we don't know what else, they may have something else also happening, but if they do, we're not aware of it. And at the time I was doing this, there were an estimated 4% of all registered quarter horses. But again, these were in the bloodlines of the horses that did halter, were muscular, not the ones that raced or did Western pleasure or, jumping or any of these other things, okay? So we know it's a genetic mutation and we know it's autosomal. What that means is that it's not on the X and Y chromosomes that determine sex, gender, okay? It's on the body cells and the muscle cells. So in other words, it shouldn't matter. It shouldn't be more common in male or female. And we find out that it's not. So here's what happens. In the DNA, you're supposed to have a guanine in this location. That's a specific way that it can be configured. And instead of it, you have cytosine. It's a different one, which leads to a different amino acid. You have leucine instead of phenylalanine. And leucine and phenylalanine, leucine has less atoms on it. It's smaller. It's physically smaller, but the place where it connects is the same. The shape is the same, but then this one's smaller, which allows the leaking of the sodium. And this just tells you where it is. The X6 region of domain 4 of the alpha subunit of the voltage-dependent sodium channel protein of muscle cell membranes. That's where it is, and results in leaking of sodium through the pore. Okay. Now we're going to start seeing the pictures. All right. So this is what is a membrane? Okay, along the membrane. Here's the outside of the cell, like the blood. Here's the inside of the cell. Down here at the bottom is the inside of the cell. And you can see there are 4 units, 4 subunits. They're going to form a circle and become a pore. If you look right here, this is the exact location where you have that leucine instead of phenylalanine, and you have that defective pore right here. These other things that were found in people, here, there's one over here on the other side of the number 6, if you can't, my pointer's not working, on the very right side. And then here you can see some of these other locations. For paramyotonia congenita, you see it right here. It's on the right side of the 3, the number green one, the third one. And then over here you have HPP, threonine replaces methionine. So this just shows you how little mistakes can happen in different places, all on that same pore. And here's what it looks like when you put it into the membrane. So it folds. This is the stretched out version that we just looked at. And then it folds into this place, and this is the pore in the middle. And this is what it looks like floating in the cell membrane. So that's what we're looking at inside the muscle cell. Okay, kind of cool, especially if you like to color things, if you like to make drawings and color them. Okay, I'm just going to quickly do this because it's not terribly relevant, but they looked, in order to find out how many of these horses there were, they took samples from 1992 to 96. They all traced to impressive, and they found 63% were normal, 36% were heterozygous. In other words, they had one defective and one normal gene, and then only 1% were homozygous. So they were doubles, okay? And then they also looked at stored samples, and they found 4% and 0% and 96%. So earlier on, not as many, but then we were getting more and more and more of these horses with the problem. So here comes the mechanism of action, which is also fun, but so there is extra potassium in the diet or from any reason, but it's usually diet. There are other ways you can get it too, but whenever the potassium goes up in the blood, doesn't matter why, potassium goes up in the blood, pressure, so you have two positive ions, and you're supposed to have sodium in the blood, you have too much potassium, and the sodium starts leaking through the muscle cell. And it's, people have gotten this wrong a lot trying to talk about it. It's not a potassium channel. It's too much potassium, but it's a sodium only channel. Okay. So it leaks through that. Then the muscles depolarize and fire again, because that's what they're supposed to do. So they'll start shaking. You'll see the symptoms. Then the potassium is going to leave the cell. Once the potassium comes in, then the body, it flips, depolarizes, and all of a sudden you're trying to get the potassium back in the cell and the sodium back out of the cell. You'll see a picture in a minute. And so then the increased extracellular potassium, and then the potassium is excreted by the kidneys, and then you have reuptake again. So it's trying to fix itself by putting these ions back where they belong. All right, hopefully the picture is easier to understand. All right, this is the wonderful creation of this. If the pointer isn't working, oh, it is good. Okay, so we have dietary potassium coming in. We have increased potassium. That also increases insulin, and it changes, some other things here. But this pour doesn't work correctly. So with all this extra potassium, we have the sodium leaking in. Okay, when sodium leaks in, the muscle fires, it starts shaking, and then you have sodium going out because it's too much, because we got to get the potassium back in. And here's the main way it comes back in. You have this ATPase, it uses energy, and it kicks out sodium and brings potassium back in. And in the working muscle, it actually helps to fix this if the horse is walking, or sometimes they can even trot, but you got to be careful. Okay. So anyway, the basic thing is happening here, that it's fixing it. It's all trying to fix it. Up here, we're just showing that we're going to the adrenal gland. We're increasing the hormone aldosterone, which is causing more excretion of potassium through the kidneys. And we're resolving this whole thing and getting it back so that it can fire again. Like if the horse was going to be running, we would have to keep fixing it. And it's a good thing that when a horse is moving, this tends to fix itself. Okay. But if it can't fix itself fast enough, they can fall down and they can be dangerous. All right. So we're in the weeds here. Okay. Again, clinical symptoms, wide range. There are diseases like this is breakdown of muscle, rhabdomyolysis, colic, seizures, respiratory conditions, and choke. These were the things that were already happening that vets knew about, but they had never heard of this. So they misdiagnosed it. You have fasciculations, you have muscle stiffness. They will look weak. They will yawn. Now, these horses did not feel bad. They were not panicking or, feeling bad. They were just, doing their thing. There's a third eyelid, a membrane that can cross their eye. That's a kind of a dead giveaway for that. I'll show you the dog sitting in a second. It means they're down, can't get up normally. And then of course they can find them in their stall, or they have to be euthanized, which is sad. There's what the dog sitting looks like. They're treating them. So they can sit up, but they can't stand. Okay. Now, the other thing, which is totally different than the muscles, is the heart. And again, like I said, it's the electrical conduction system of the heart that causes I'll show you what it looks like. Okay, here's an ECG, electrocardiogram. And let's see, these are horses. So at potassium of 4.3, this is your normal, you know what it looks like, an electrocardiogram, your heart. It's the beating of your heart. When potassium goes up to 5.3, it's stretching out. You can see that. Up to 8, look at how stretched out it is. And this is where it'll just stop beating. If it stretches out too much, it will literally just stop beating. And here they gave the horse calcium. We did calcium gluconate. Both glucose and calcium help put it back together, get the potassium back in the cells. So they're just showing what could happen. And here's basically what it looks like in the horses or heart failure. I mean, this could actually be either one. So here's your normal, heartbeat, 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 heartbeat. So at 5 to 6.5, it's starting to stretch out. At 6.5, it's more stretch out. And 8, it's not a normal heartbeat. Heart rhythm stops. Horse dies or person. Okay. So 2 things are happening. So how did they diagnose it? They started with hair. I think they started with blood, but then they're able to do it. You have to pull the hair out by the roots and send it in, and they're able to fix it. And they had some other ways to figure it out here before they had the DNA test. They used muscle myograms, cardiograms, or they fed them potassium and watched to see what happened. And obviously, if that horse has it, that could be dangerous. Now, here's the key takeaway right here. This is huge. They said if a horse had high potassium, then it had HYPP. But horses actually start having symptoms, in my research, at about 3.79, which is right in the middle of normal potassium. So if you're trying to diagnose with high potassium, you're going to miss virtually every one of these horses. I'll show you how in a minute. How are we doing for time? Okay. So we know that we have to do dietary management. That's something that I ended up proving. But before that, you don't want them in a stall. You want them to move around. They were actually feeding a diuretic, which causes them to urinate more, called acetazolamide. And they would put them on these horses on them all the time. And it did work. It helped. If they're having an episode, calcium carbonate. Now, again, these things work for people too. There's similar problems in a very few people. Okay, so before you do research, you don't know the history, you have symptoms in progress, and you don't know anything else about that horse. So you can use that to develop a research hypothesis. And when you do the research, you know the history and you use it to design the research. You monitor before, during, and after the symptoms. You control other variables, and that's big. You can't do a nutrition study if you don't control the exercise. Okay, right. All right. So the objectives: document and quantify HYPP episodes in the positive and negative horses. I used varying concentrations of potassium, 3 different concentrations, and we couldn't exercise them. No forced exercise. They lived in groups of 2 in
Recording
small
stopped.
pens. Okay, I don't know what to do about that. I guess you guys have to start the recording.
Recording in progress.
Okay, so again, we're going to quantify the episodes. We're going to feed 3 concentrations of potassium, and then we're going to, that was my separate research, quantify differences in potassium absorption and excretion. So a bunch of things we were doing. So the diets, we had to use 65% concentrate or a pellet, and then only 35% hay. Normally a horse would be fed about 90% hay and 10% concentrate. But in order to get the potassium in, we had to use a potassium source. So what we did is we fed them 2 meals a day, very, timed exactly. And we fed them at 12-hour intervals, exactly 12 hours apart. We formulated using the NRC minimum for maintenance. We made sure we met all their nutrient needs. So we had 3 concentrations. We had diet A with no added potassium, and it had 1.1% potassium. The idea was for it to be 1, 2, and 3. And then when we actually analyzed it at the end, it was 1.1, 1.9, and 2.9 is what they ended up to be. And these are color coded. So we used 12 mature quarter horse broodmares, descendants of impressive, DNA tested to be HN or normal. We randomly assigned 2 of each into 3 groups. And of course, we did all their routine health maintenance. So this was the Latin square. So on the first group, got diet C, and then diet B, and then diet A. In the first group, period 1, group 1 got diet C, group 2 got diet A, and group 3 got diet B. And again, 1.1, 2, I put 2 and 3, but it's, you know. So for each part of the Latin square, we spent 7 days getting them used to the diet. Then we drew their blood for potassium concentration. And this whole time we were observing them. We had notebooks, we had people watching. I had students watching the horses and making notes of if they were having any fasciculations or any issues with their muscles. And then we drew the blood again at day 21. Okay, so day 8 and day 21, we drew blood and we compared the blood from the beginning to the end. This again was a different project that I used the ponies for, and we found that 98% of the potassium was absorbed before the hindgut. So in the stomach and small intestine, very absorbable. This is different than it would be in nature because we added potassium citrate, which is, you know, it's easy to absorb. So if the potassium was in the hay, it would be harder to absorb. So obviously this is a research thing that we found out. But 99.9% of the potassium in the diet was absorbed. Most of it, almost all of it, was excreted in the urine with a minor amount going out in the feces. In other words, that didn't get absorbed. But here's when it starts to get interesting. More was retained from diet B than diet A or C, and there was no difference by HYPP status. So as we fed these diets, the way they were able to absorb, digest, utilize, and get rid of the potassium was the same with the HYPP and the normal horses. So this is kind of fascinating. Okay, this will be easier when I show you the diagrams. Okay, we saw a pattern after meal, postprandial, in plasma potassium from diets B and C. Between the first meal and meal 27, they got better. They adjusted to the extra potassium and got better at getting rid of it. Another fascinating thing. We had increased average potassium after diet B, and again, no difference by HYPP status. So we were learning how horses metabolize potassium, and this is what it looked like. The positive horses up here, the negative here, and you can see they started out, now this is 3.5 and 3.7, so they were slightly different. But when they were fed, bingo, it goes up here, kind of, you know, and this is the difference between the potassium that's getting absorbed through the front of the horse. Remember? The citrate, the potassium citrate, that's like if you ate salt versus if you got salt out of the food you're eating. Okay, so that's why I think we got this little dip here. Okay, now here's the fun part by diet. So all the horses were put back together, the HYPP positive and negative, all put back together. So on diet A, pretty much, I mean, this is 3.25, doesn't basically change, okay, because they were just getting a normal diet, 1.1% potassium. Diet 2, again, there was a little bit of a difference in those horses to start with, and stayed a lot higher. And diet C, which was the most, is weird. It went up and it came down quicker. And the only thing I can think of for this is that it was such a shock that they just worked really hard and got rid of it sooner. But that's not the key thing. When we do the symptoms, that'll make more sense. Okay, so HYPP symptoms. If Okay, if there are no symptoms, it's a symptom index. And this is something I had to create because we had to have a way to explain the relationship between the blood potassium and the symptoms. So 0, they didn't have any. 1 point, we divided the body into 5 sections: the head and neck, the front quarters, the body, and the hindquarters, and into 5 sections so that we could say, you know, at this time, were there fasciculations on 1 through 5, one, you know, of those different 5 areas. Then if they had a problem moving, like it looked like they couldn't move their front or hindquarters, that was another 1 point for one or both of them. If the third eyelid prolapsed, that was another point. And if they actually went down, if they actually could not stay up, that was 2. So it could be 10. So you could have a horse with 0 symptoms at time 6 a.m. and then they could go all the way to 10 at time 10 a.m. for one individual horse. Okay, so the results of the symptom index. Diet A, they didn't have any symptoms. They were not, it didn't matter if they were positive or negative HYPP, they didn't have any symptoms. Okay, normal diet, 1.1% potassium. Diet B, and this is the percentage of potassium. No, wait a minute. No, this is symptoms. Okay, so at the first meal, they had symptoms 1.5% of the time, and here they had 2, 4. Okay, this is I'm looking at the wrong slide. Hang on a second. Sorry. Symptoms, okay, right. The symptom index is one part of the body. It goes from 1 to 10. So we had a 1.59 here, and then we had a 1 over here, right? So 0, these would be zeros. I was thinking blood here. Okay, so not very many symptoms. I mean, that's good. But then on diet C, they had a 2.42 after the first time, and then the symptoms went down and they were the same from diet C after 27 meals and down here. So again, this is physiology of how the HYPP symptoms happen relative to the diet. Okay. Okay. Here's the one. If they didn't have HYPP, they didn't have any symptoms at all. Okay. If they were fed diet A and they had the disease, the disorder, again, no symptoms because they didn't get enough potassium to trigger that defective sodium channel. But here's the weird part. After 52% of the meals, so half the time when they got a meal, they had some symptoms. Okay, they had at least one symptom half the time. And when they were fed diet C, they had at least one symptom 2/3 of the time. After every meal, 2/3 of the time they would have symptoms. This is huge. That's a lot of a problem. Okay, so I covered that, covered that, covered that. Now, the other interesting thing, they were twice as common in the daytime, the symptoms, as they were at night. And I explain that later on, but there's kind of a postprandial thing where when you're quiet at night, it alters your aldosterone, your hormones and things like that. That kind of explains that. They're quieter at night than they are during the day. Again, this probably is the biggest takeaway for anybody with horses, anybody with people looking at diet, potassium, and physiology, because it was the amount of potassium in the blood that mattered. And it didn't matter if they got it from diet A, diet B, or diet C. When the potassium went up, and in this, it was for diet, but for any reason that the potassium went up, look at how narrow this range is: 3.74, 3.81, 3.78, and 3.84. How narrow this range is. That's when the symptoms were triggered. Okay, so that's like the magic line And that's why we have to recommend the low potassium diets. So it's when the blood gets to a certain point that that cell, those muscle cells, defective cells, don't work correctly. So at average of 3.79 millimoles per liter, you can start having symptoms. All right. And it got better from meal 1 to meal 27, which means they adapted. This is something that could have killed them, and they actually adapted to it. And so therefore, the plasma potassium got lower, and so did the symptoms, because they're related. Now here's where hopefully it'll make a little more sense. So we have diet and symptoms. All right. The diet A, no extra potassium, 1%. The blue one is diet B, and the red one is diet C. Okay, so, and here's their plasma potassium. So this is blood, and then this is symptoms down here. Blood right here, again, you can see that line right here at that 3.71 or 3.84 or whatever it is. When the blood got to one of these levels, that's when the symptoms started. It's very direct. See right here is where that arrow is, and that's where the symptoms started. And this is what they did with symptoms. And then this is what they did with diet C, the most potassium, and see how the symptoms are. I mean, the blood is higher. It literally follows the symptoms. They correlate with each other. Okay. In this particular one, this is blood and symptoms. But before we started this, I mean, the results that I've just given you were the actual trial. But before we did that, we tried it one time, and we were giving too much potassium. So one horse, when we were first trying this out, this is what happened with her. She actually went all the way to sternal recumbency, and her blood potassium went up to 7.5. Okay, this is one horse, one trial, and this is what happened. On the first day, all the way up, high symptoms, high blood potassium. And again, by day 27, she barely went up above that line and had symptoms for a short time. Okay, so it's really showing the physiology. Okay, we are, all right, 51. All right, so the main thing I want to do here now is, how do we take this research and how do we use it? What is it telling us? Because all of this is this is where I do the conclusions of my particular research. But then what I went on and did, all these things had been questioned. And so this is after. Some of this is several years, 10, 15, maybe even years after my research, where other research came in and I talked about it and just, explained that these other factors are not as important as diet. And so let me just run through and see if any of these I need to do that are going to help. Okay, this is a big one. The reason that people were breeding to this horse, because they liked the muscle in the horse, was that they thought that the horses that were HYPP positive had heavier muscling and therefore would win more halter classes. And that's why people wanted those horses. Even though they were sick, they wanted them. This research proved that that's not true. And I could have told you that, because the horses that I was around, some of them you'd look at them and they were heavily muscled, but they didn't have it. And some of them were not heavily muscled, but they did. And this was a big deal, because people with those horses, they were valuable and they were worried, they didn't want to give them up and all this was going on. But it was proven that the muscling and the HYPP disorder were not the same cause. There were two different causes. So this is like, when you're looking at a cause of something, we use Occam's razor, which says the simplest explanation is usually correct. In this case, it was a zebra, because you had two causes, two completely separate causes, and you had to find that out. That was a key thing you had to find out. So thank you for the zebra, Albert. Okay, we also found out they used to think that it was age related, but if you look at the milk of a mare feeding her baby, it's got more potassium right when the baby's small, and as it gets older, there's less potassium in the milk. And all the babies that had both, they had both defective genes were very sick as foals. So all of these had moms that also had it. Where most of the ones that had one gene that was defective and one wasn't, most of them got the defective gene from the stallion. So the mare's milk was not affecting them the same way. Okay. They had one good gene, one not, but they didn't, the mare's milk, her physiology wasn't affecting it. It was just a baby. All right. Again, not dependent. They thought at the beginning that it was the males would get it, but no, it's autosomal. Doesn't affect it. That isn't affected. Again, some of these things, day versus night, a circadian pattern of potassium excretion has been reported in humans. So there will be differences. Like I said, I did talk about that. The animals that had both of these were very sick. I didn't have any of these, but again, if they were really sick as a foal, they may not have made it. So the fact that it was the blood itself, the amount of potassium in the blood for these horses that had the mutation is important. The fact that they were able to adjust, okay? Those were important things about it. And exercise, only a non-exercising muscle can have HYPP symptoms because every time the muscle fires to work, it starts the whole thing over. So only if it is sitting there. And that's why you have to control the exercise. Right? And again, that's my theory. I think I'm just going to, there were other things at the beginning. They thought that the stress of weaning, transport, surgery, anesthesia, all these things. And by the way, those horses do have a very bad reaction to anesthesia. Because again, it changes the physiology. So we keep the diet below 1.1% potassium, or we let them graze because all the potassium that they eat in the grass is 70, 80% water, and it spreads the potassium out. Okay. All right. I don't think there's anything else on here that's going to be super relevant now. Oh, what happened with the breed associations? Okay. All breed associations for cats, dogs, horses, everything, they have certain rules. If they classify something as a genetic defect, they want to breed it out of the population. For instance, with horses, there's always been, you cannot register horses that have what's called a parrot mouth. Parrot mouth means I don't know if I can do it with my hand here in front of me, but it means that if the upper teeth are way sticking out in front, like if your upper jaw is sticking out and your lower jaw is low, those horses have that defect and they can't eat normally. They're not going to survive. So that you cannot register your horse if it has that. And there are a whole bunch of other ones. If they only have one testicle descended, that's a trait they don't want. So there were always these traits. So in 1992, they started noting it. You had to get your horse tested for registration. And then they started this mandatory testing, but you had to have it on the registration certificate. So if a person bought this horse, they would not be, unaware of a genetic defect that horse had. As of 2007, they would not register the HH horses, but then people, again, they liked the muscle, so they were still breeding the other ones. And they stopped registering all of these horses, the NH horses, probably 10, 12 years ago. I don't remember exactly when, but the different breed associations did different things. So again, an association, a breeder of horses, dogs, cats, cows, anything. It's the ethics within that organization that's going to decide whether they're allowing things like this to keep going on. I mean, we have the animals, we take care of the ones we have, we do the best we can, but we don't perpetuate a problem that they can't live normally is basically what this is about. Oh, I do want to say this just real quickly. These are different genetic mutations in horses that horse people have to deal with. HYPP is in the sodium channel, glycogen storage, polysaccharide storage, myopathy. They have to have a low starch ration. RER, recurrent exertional rhabdomyolysis, another one, muscles get broken down. They have to have a low starch diet. Bone formation, developmental orthopedic disease, they have to have low starch or low glycemic index rations. There is a low amylase. They don't have the enzyme to break down amylase, which can result in founder. You can give them enzymes or a low starch ration. Horses with a lot of weight markings, they can have photosensitive problems, and you don't feed them all-site clover. So again, there are a lot of things out there. I just got to show you those are my, and they're not HYPP. I never owned HYPP horses because I knew what the problem was. Okay. Questions?
Anyone have any questions? That was a lot to cover, Dr. Judy.
Right. And that's the problem with it. But there was no place to stop in the middle. So
no, I'm not complaining.
Yeah.
Not complaining at all. And it's very interesting how what you saw proved that even with a mutated gene, diet made a difference.
Mm-hmm.
And then it was also very interesting, and that's probably why in the name it says periodic, is the time of day made a difference.
Mm-hmm.
So very interesting. So now the question is, and Kathy has put this question up, and this is a question that I was going to ask as well, is how does this translate to human needs for potassium?
Okay. First of all, I was comparing normal horses with it, normal as far as that sodium channel is concerned, with horses with this disorder. So I have never met anyone with this, any human being with this problem. I've researched it, but I've never met a human with it. And we're unlikely to meet humans that have this. So we're going to throw away if there is a human that actually has this, then they have to very carefully control what they eat and not get too much potassium, just like a horse would. But here's the difference between horses and people. The main diet of a horse is hay, forage, pasture, and they all have somewhere around 1% to 2% and even up to 3% potassium in their normal food. The diets that people eat, we tend to eat too much salt if we eat heavily salted snacks and all those kinds of things. But we've been told to keep cutting back on our salt, cut back on our salt, cut back on our salt, which is incorrect because we need sodium chloride in order to form the stomach acid, the hydrochloric acid that helps us break down the minerals and the proteins and stuff in our stomach. So your average person doesn't get enough potassium if they don't eat a lot of vegetables. And how many people do you know that eat a lot of vegetables? And you will find with people, almost all older people get put on added potassium to make sure they have enough, because they can draw your blood, and preferably it's fasting. This is why when people say you get your blood drawn, fasting means you didn't eat in the last 12 hours. You saw how that potassium went up and down after each meal in those people, right?
Mm-hmm. Mm-hmm.
So your blood can be drawn if you're an elderly person, you're not eating very much, you might not have someone to cook for you, you might not get vegetables very often. If your potassium is low, you're going to feel terrible, and it's an essential nutrient. And so we need to make sure as people that we're getting enough sodium. or I'm sorry, potassium, and we have a good mechanism as long as our kidneys work well. You can see from my diagram, you're trying to get rid of that extra potassium. Whatever you eat, horses are always eating too much potassium. They're getting rid of it through the kidneys. So if you have kidney problems, then you are going to have potassium problems, right? So for people, we have to eat more sodium than they tell us. We have to eat probably double. And I did talk about that in that salt lecture. You can go out and look at one of the ones I did before called Salt of the Earth. And we went through, a lot of that information. And Dr. Wallach talks about that a lot. That's one of the things he talks about. But as far as potassium is concerned, you do have to get enough. And there's always a caution with potassium. And that's why a doctor can only, or a pharmacist or whoever formulates can only do a small amount of potassium in each tablet, because you saw how the high potassium actually stopped the electrical conduction system of the heart. It's actually used as a euthanasia shot, whatever they do for an animal that has to be euthanized. They use high potassium. So you have to be very careful with it. It's not something you just go around and add too much or mess around with it. Okay, so hopefully that's not confusing. You can check your potassium level if you don't think you eat enough vegetables, because that's where most of the potassium is in the vegetables, right?
Mhm.
That's also in meat too. So every cell, it's in the cells. And the sodium is in the tissues, like blood, that type of thing. Did that answer the question? I hope. I don't know.
I think so.
But from what all this stuff I said about potassium in horses, it's not the same as us, because we don't eat hay and forage as a normal diet. We eat other things. People eat other things. And those things don't have as much potassium usually as the things horses eat. Okay.
Well, and even the things that in nature would have potassium, we eat it in a processed form.
Yeah.
That reduces all the nutritional value.
Right.
Yeah. And then we have Harry, the healer, out on Rumble. I can read part of this, Harry, but he does say how it is interesting information that the horse was our gift from the creator, and he says thank you. And let's go over to Keely. Huh?
I just said thank you, Harry.
Oh, Keely, go ahead and unmute yourself.
Hi, Dr. Judy. How are you today?
Hi, Keely. I'm great. How are you?
Oh, fantastic. So really what you're telling us is that potassium is sort of like the metabolic barometer for us, whether we're animal and or human being.
Well, potassium varies. Okay, here. You opened a door. Okay. Plants are based on potassium. Okay. They need turgor pressure to keep a plant upright. It has liquid and it has potassium to keep it, turgor pressure is what they call it. So if you puncture that plant and the liquids come out, then the plant will droop, right?
Okay.
But plants do not have sodium. They don't need it because they don't move. Animals have both potassium and sodium because they need it for nerve conduction to be able to think, and for muscle movement to be able to move. So the difference between plants and animals, and by the way, plants do all kinds of things that are very creative as far as adjusting to move towards the sun and all this kind of stuff. But it's different than what animals are able to do. So Can you phrase that again the way you phrased it for me?
Um, Potassium, it's one of the things that we both need, that it's like a barometer in our bodies. So if my understanding from just sort of like reading Dr. Wallach's, stuff, that high potassium, it says that something is off in the metabolic part of the cell. I think is what he said, that if the potassium is too high, that there is something wrong with the metabolism of that cell. I think maybe that was the statement that was made.
Okay,
And
where was he measuring when he said that? Was he
I
talking
think
inside a cell or in the blood?
I think he was referring to the cell sort of being as a battery, and that it could short circuit and result in being paralyzed. Does that make sense?
He may have been talking about a necropsy where they measured the amount of potassium within a cell and found it to be incorrect.
Okay.
Whereas your typical doctor that's not a pathologist would have only been probably looking at blood. They would have been less likely to be looking at tissue. But since he looked at tissue, yeah, I mean, but again, I think the way, first of all, both of those ions are required with water in certain and very specific amounts to keep the right amount of pressure happening within the cells. So we all know that if you drank too much salt water, your cells would explode and you'd die, because wherever there's sodium, the water's trying to come in to balance it out.
Gotcha.
So the whole concept of sodium and potassium is that you only need one in plants because they're not doing the same things that our nerves and muscles are doing. But for us, for the animals, we need both. But here's a fascinating thing, and I looked this up a while ago because I wanted to find out. And I went through Dr. Albrecht's books, who Dr. Wallach learned from. And I did find in the literature that it said that if plants are deficient in potassium, they can use sodium. So you can have a plant out somewhere where there isn't enough potassium, but there's a lot of sodium, and those plants are able to utilize that. I thought that was fascinating myself. But anyway,
Mhm.
so again, the ions have to do with water movement, making sure you have the right amount of water and electrolytes, mainly sodium, potassium, and you got magnesium and you got calcium ionized and all that kind of stuff. But yeah, I mean, I'll take it. I'll take it. I mean, I think he probably that's probably what he was talking about, is when he'd done pathology
Gotcha.
on tissues.
The other thing I was sort of fascinated with, you were talking about the cause and the correlation, of potassium. When you talked about the babies, the horses, the breastfed, how they had the higher potassium and then it reduced, over those months.
Yep,
It sort of speaks to sort of how important breastfeeding our children would be in maintaining some of those balances in their bodies as well. And then
exactly.
the other question was, I was really sort of fascinated when you were talking about sort of the muscles, um, and that particular correlation. What I'm wondering is, so given all the science that has been done on these animals, how do you compare that muscle thing to people who are like weight lifters, or who are have a bigger muscle mass that is normal, recognizing what those balances or imbalances would have to be in order to sustain their bodies?
That is a great question. Another before, I mean, when you first start talking about muscle, there are different muscle fiber types. So you have people that are lean, that seem to be lean, and they do long distance running and things like that. You have horses, again, built that way too for endurance. And then you also have these very muscular power builder, like that horse impressive in the horse world. They actually have completely different muscle fiber types. So you cannot necessarily take, I mean, you can improve the shape, size, and strength of any muscle or muscle cell, but it's within certain limits, and the genetic limits are the muscle fiber type. But So when you think about if you go and talk to someone who is a bodybuilder, an extreme bodybuilder, you would not believe the amount of food that they ingest in order to keep those bodies the way they are.
Yeah. Eggs and
Among
tuna
them.
fish.
Yeah, I mean, and also, well, so do the endurance people. But I mean, it's the more work the body does, the more nutrients the body needs. And one of the things I want to talk about at some point, because it's so important, is the whole, and Dr. Wallach has an audio tape on this that's wonderful. Exercise without supplementation is suicide. That's the name of it. It's one of his audio recordings. But it's the concept that we're all talking about. People want, if you want to be healthy, but you're not doing anything, if you're a library type person like I am, and I can't do a lot of exercise because I have so much metal in my neck and my back. I mean, I literally have limits on how much quote exercise I could do. However, I still take care of all the animals. I still move around. I do very well. And I was, I'm lucky I'm not in a wheelchair, which it was predicted I would be in a wheelchair, probably unable to move by now. And I'm not. So again, that's from feeding all the parts of the body. But the more exercise you do, the more nutrients you need to maintain that. And it's fascinating that people don't understand that concept. Jim Fixx, Dr. Wallach has talked about a lot of these people. There were exercise people that they wanted to prove their point so badly that they refused to take any supplements because they wanted to prove that they didn't need supplements, and they died very young. One of them died running. I think it was Jim Fixx. This is all stuff in Dr. Wallach's things.
Right.
I've also listened to a couple of other people who talk about this kind of thing. But, again, if you look at some of the earlier people who did a lot of extreme exercise and sports and things, if they weren't figuring out how to supplement, then they were having a bad outcome. So the amount of exercise relates to the amount of nutrients you need. And in all these species, all the exercise physiology, all the charts, when we figure out the nutrient requirements, it's always separated by workload. And with horses, you have a horse that's growing and racing. They start racing these horses very young. That's another, it's an ethical thing. They do it. They start training thoroughbreds at a year and a half. They start doing, certain events with quarter horses at 2. They do, they're running the quarter horse races right now with 2-year-olds.
Wow.
They do it. They win races. I mean, it's part of what they do. But maybe it'd be better to wait a little longer. That's part of my first research project which was with the young racehorses. We were looking at bone strength and, bone breaking and all that. So anyway.
The reason I asked that question is I have several grandchildren that are full out athletes. I mean, literally, my granddaughter, as you know, we put together a protocol for her, and she runs a mile in 5 minutes and 24 seconds. So, which is almost unheard of. She beats the Division I college rate. So
that's amazing.
Recognizing that you have all, you feed the horses different things based on their muscle mass. How do we learn how to do that for young girls and boys that are actually growing, through puberty at the same time? And we carb load them. They're on all the plants. They're on all the plant-derived minerals on a total protocol. And then we increase them 2 to 3 times when they're actually in activity. But it would be really neat to have, sort of like what you've done with the animals, done for the people and kids especially.
There is a lot of research out there.
Okay, great.
There is. It's out there on people, because the thing is, where will people spend research money? And they will spend it on people. They will spend it on production animals. Any money that gets spent on horses is just like a gift from somewhere, because, people don't see the benefit of spending money on horse research for the most part. I mean, think about it. If you want to learn something, and you can have generations of rats every 6 months, you know, but a horse, you got to wait 4 years. You
Gotcha.
know what I mean? So there is a lot of research out there about that. You know, I haven't looked up a lot of that recently, but I did go to the equine exercise physiology meetings a week or two ago. I spent a couple days listening to all that, and it was fascinating. There's a lady that I didn't even know that has been at Texas A&M, and she was half animal science and half human kinesiology, exercise physiology in her appointment. She's retiring, so she's been there, I don't know how long. I had never met her, but she was doing a talk on mitochondria and how
Nice.
are we feeding it was fascinating. So, but there is a lot of information out there on human athletes.
Okay, great.
And it's a question of finding it and applying it. And, you know, a lot of it is trial and error too. But you'd probably be surprised at how much is out there. Again, one of my pet peeves, you can't necessarily find it all without paying for journals. But I bet we could do some research and find out, you know,
Okay.
some things that would help. The
Well,
other
thank you
thing
very
with, you know, your women athletes, you got the menstrual cycle. You better allow for that also, or, you know, a lot of these athletes just become non-functional because they're not getting enough nutrients and they're using them all up running and that kind of thing. So for whatever that's worth.
No, thank you very much for your thoughts. I appreciate it. I will contact you via your email.
Yep. Thanks for the question. Yep.
You bet. Bye-bye.
All right. Thank you, Keely. Great questions. And we have Olga commenting, saying, just like dogs, some are very lean and extremely strong. And Kathy says, extremely interesting information and presentation. Thank you very much for sharing your research, Dr. Judy. And I want to say thank you as well, as this is well,
yeah.
As a country kid raised with horses,
yeah,
you know, I didn't get as deep into it as my little brother did. But man, when you go researching, you dive in deep, and it just shows your passion for nutrition and the species themselves. So thank you for sharing that with us.
Thank you. For me, I was with horses. Oh, I could show you this. I showed you guys. My sister was with Heritage Makers and they got moved into Longevity, and she's been in there for quite a while, but she is a wonderful, she does photography and all that kind of stuff. So she made a cup for me, and it's not going to be easy to see, but that's me with my science fair project on horses.
That's adorable.
And then here's my first horse, Buckskin. And let's go around one more. And here's me walking up to him. Whoops, my cousin had took that in black and white. My first horse. But again, all of you guys do your longevity. Keep your photos and do cool things.
Absolutely. Nice plug for YGY Photo
exactly.
or Y Photos.
Yeah.
Where they do have that opportunity to take your photos, put them into something that is you can hold on to as memories, whether it's on canvas, mugs, pads.
Yep.
So lots of great stuff with longevity, which, folks, this program is being sponsored by Daily with Doc, where the only thing that we offer on our website is through longevity, because we believe in the nutrition for solutions so strongly. We don't need anything else. So thank you again, Dr. Judy Reynolds, folks. If you have questions, you want to reach out to her, it's Dr. Judy Reynolds at gmail.com. So thank you again. If I could get our co-hosts up on the screen, that would be fantastic. Dr. Judy, do you have any closing remarks?
Oh, I think I made enough remarks at this point, but if you send, it's Dr. Judy Reynolds at gmail.com, and then put DWD in the subject
Subject.
line on your emails, because I get way more emails than I can even get through, and I don't want to miss it, you know.
Mhm.
So you get a priority from this program over just about everything else except catastrophes among the family and, you know, stuff like that. So
Awesome. Well, everybody smile.
mhm.
Smile, Dr. Judy. And thank you, everybody who is here live with us in our live Zoom, as we are here Wednesday, Thursday, Friday from 12 to 1 Pacific, 1 to 2 Mountain, 2 to 3 Central, 3 to 4 Eastern. And use your favorite browser to find out what time zone it is in your time zone, so that you can join us live as well by going to zoom.dailywithdoc.com. You do have to be logged in with a valid Zoom account and register, and then you'll be able to come in the next time. So get back with the person that shared this program with you, folks. Let them know what you thought, as Youngevity does offer nutrition for animals as well. And we'll talk more about that on another episode. So thank you, thank you, thank you to everyone that you see on the screen. Dr. Judy being our keynote speaker today. Thank you again.
Thank you.
We have Albert joining us from South Africa as our gatekeeper. Thank you, Albert. We have my executive protection manager, Ruth Allen. And she and Sherry are both kind of doing double duties, as they're keeping an eye on things out on the different platforms, in the chat here, making sure that if there's any questions, comments, I get to see them so that I can read them here on the show as well. And just all these people I hold near and dear to my heart, and those that are not with us, we keep you in our thoughts, as I know that you are here in spirit. And thank you to each of our guests and those that made comments and came on with questions. That's what helps us help you and everyone else that's not able to ask the questions, but I know somebody's thinking that as well. Again, my name is Becca Dukes. I don't know if I said that in the beginning. I'm a certified naturopathic practitioner and certified holistic health coach, and it is my honor, privilege, and passion to help you as an individual realize how empowered you are, and what you put in your mouth and have in your environment really does make a difference on your health in the short term and the long term. So folks, thank you so much for joining us here on Daily with Doc and Becca. And again, if you're watching us on any of the platforms, like, share, and especially subscribe. Let us know where you're joining us from. If you have any questions, you can always email, and this is in general, not necessarily directly to Dr. Judy, but you can still get those questions into us. We'll get them to Dr. Judy. And that's questions@dailywithdoc.com. Now, if you want to get with a certified holistic health coach, you're not working with somebody already, we do have a call team standing by at 855-949-3377. Again, that's 855-949-3377. So until tomorrow, when we have Pharmacist Ben back with us, have a wonderful day, and don't forget how empowered and special you are, divinely created. And the body can do amazing things when you give it what it needs. Bye for now. is for educational purposes only. The content is not intended to diagnose, treat, cure, or prevent any diseases, nor is it intended to take the place of your primary care physician. The statements in this program have not been evaluated by the FDA. Testimonials are shared as individual experiences of the individual. Results vary and may not be typical. We do not make any claims regarding health or income. As an empowered individual, you do have options available. We are honored to continue to share the teachings of a founding father of the science of epigenetics, Dr. Joel Wallach, Bachelor of Science in Plant and Soil Sciences, Doctor of Veterinary Medicine, 4 postdoctorates in Pathology, Naturopathic Doctor.